Hello and welcome again. This video is a continuation of the previous video, which is the internal structure of the advanced encryption standard. And remember, last time we were talking about the byte substitution layer, which is done with the X boxes, and we also talked about the key addition layer. Now, one more layer that we didn't talk about is the diffusion layer, the third layer, which is part of the rounds. And that layer is divided into two parts. So the two parts, if you recall from that video, is that you have the shift rows and the mixed columns. Now, in this video, we'll talk about this first shift rows here of the diffusion layer. Okay, so let's talk a little bit, or recall a little bit what the rounds are. So basically, what the rounds are the following thing: you take a 128-bit block. You do a byte substitution, then you do a diffusion layer, which is composed with two parts, main parts, which is the shift rows and the mixed columns, and then you do a key addition layer. Now this is for round one. Remember, for round one we have a particular case, which is not true for all the rounds, which is we have two keys that are inputting here. All the other rounds will only have only one key. Now, so we talked about, of course, the byte substitution. So let's talk about this part here, the shift rows for this particular case. Now, just to set up the notation, let me recall what the byte substitution is in the notation here. So this rectangle represents the 128-bit block. So every subrectangle here is a 0 over 1. Oh, sorry, this is a byte, A0 through A15. Because I have 128 bits, I divide it into bytes. So a chunk of bytes here. So every byte, I'm going to denote it. The first one, I'm going to denote it with A0, A1, all the way through A15. So I have 16 bytes. Now, as we saw in the previous video, you're going to apply the X box to that. And once you apply it, then you get another 128-bit block. And of course, it's gonna be divided into bytes, and the bytes I'm gonna call them. This guy over here will be B0, B1, and so on up to B15. Now B0, B1, all those things denote bytes, so they are 8 bits each. So B0 is an 8-bit, B1 is an 8-bit, and also all the way to B15. So I'm gonna use this notation now. So after we are done with the byte substitution layer, what comes after that is the shift rows layer. So, and I'm going to use this notation, the B0, B1 through B15. Every time I write down any of those, it means is a byte or 8 bits. All right, so how does the shift rows sublayer work? So the first thing you're going to do is you're going to imagine that you have this rectangular array or matrix, and you're going to organize your bytes in this way. So I have four rows, 1, 2, 3, 4. And 4 columns, 1, 2, 3, 4. You're gonna write down the bytes that are here of this 128-bit block. Remember, the B0, B1, all the way through B15 are bytes. You're gonna organize it like this. You're gonna organize it by column. So you're gonna start with this column, B0, B1, B2, B3, and then go to the next column, B4, B5, B6, B7, 8, 9, 10, 11, and so on. So you organize it like this. So you put them in this rectangular array in this manner. So you start from here, 0, 1, 2, 3, and then continue to the next column, 4, 5, 6, 7, and continue to the next column, and so on and so forth, according to the order in which the bytes are right here. And the reason we're going to do that is because this shift rows is exactly that. We're going to shift the rows here in this rectangular array. So once you put your bytes here, in this rectangular array, and remember that every one of those B0 all the way through B15, all of them are bytes. All right, so how are you going to do that? So you see here, I have some writing already. So we're going to shift the rows. The first row is not shift, but basically what it means is you're not going to touch this row. So you're going to just leave it like that. So this row is going to stay the same, B0, B4, B8, B12. Just leave it like that. The second row is gonna be one position left shift. So what that means is I'm gonna look at this row, and I'm gonna shift to the left. So I'm gonna take this guy that is right here, B1, and I'm gonna move it to the last position, and I shift all the ones like that. Now we did something like that when we were doing the key schedule for the AES. So this is the left shift. So again, the second row, what you do is you move this byte here to this position here, and then you move the ones B5, B9, and B13 to that direction. The third row is gonna have a 2-position shift to the left. So I'm gonna move, in this case, this is gonna be the third row, the whole thing. So I'm gonna move the B2 to the end, and I'm also gonna move the B6 to the end. And the last row is gonna be shift 3 positions to the left. So in this case, I'm gonna move the B3 to the last position, the B7 behind it, and the B11 behind it. So that's what the shift rows is doing. Is basically shifting the rows of this rectangular array. Now remember, the way you write down your array for, or the 128-bit is just by columns like this. So you arrange it by columns, and then you're gonna shift the rows depending on whether it's the first row, the second row, the third row, and the fourth row. The first row doesn't have any shift, the second has 1, the third has 2, and the last one will have 3 shifts. Okay, so let me explain a little bit more what I'm doing. So after you do this, the shifts, you're gonna get a new array, or a new a rectangular array of bytes, and from there you're gonna read what comes out of the shift rows. So let's look at the example. So let's say this B0, B1, all the way through B15 are my bytes, which could be any combination of 8 bits. And so I'm gonna construct a new matrix or a new array using these shifts. No shift for the first row, 1 for the second one, and so on. So what happens? What is the first row of the new matrix or the new array? The first row of the new matrix is just this guy over here, because I don't change it at all. So it's gonna be B0, B4, B8, B12. So the first row will be B0, B4, B8, B12. Now the second row has to change, and remember what I said is only 1 position left shift. So I'm gonna move the B1 to the beginning. So basically what I have here is this. I have in the second row, the original has this. The original has B1, B5, B9, and B13. Now that's the original. That is I haven't changed it yet. So there's B1, this one here, B1, B5, B9, B13. That's what I have there. Okay. 1, 5, 9, 13. And then for the second row, I need to do a 1 position left shift. So basically what that means is I'm going to move the B1 that I have here to this position. So let's say I'm going to erase it from here, and I'm going to put it right here. This is going to be my B1. This guy now is the new row for the new second row for the matrix. So then the new array will have, in the second row will have B5, B9, B13, and B1. Now what happens with the third row? So let me do all of those. So third row. So let's look at that one. Third row. And this will be the third row of the new matrix. And then from that matrix, what we're gonna do is we're gonna read the new 128-bit. So the third row of the new matrix. So what I need to do is I first start with the third row of my original array, which is this guy over here. This is my original array. I'm gonna start with the third row. So I'm gonna start with B2, B6, B10, and B14. So let me write that down. Let me go all the way over here, and that was B2, B6, B10, and B14. All right. And I remember, because this is the third row, then what I need to do is I need to do a shift of 2 to the left. So okay, so let's start with that shift. So I have to do it twice. So I have to move the B2. This B2 here. So let's do that in here. So I'm gonna erase that B2 and move it here. So it's gonna be the B2. That is only one shift. Now I actually do the next one. The next one will be, I'm gonna move the B6 here to the this position. So the B6 will go here. So I'm gonna erase it from here. So let me erase it, and I'm gonna move it to that position. That will be B6. This will be the new, this whole here will be the new third row of my new array. So it will be B10, B14, B2, and B6. And so I have my first three rows. I have the first row, the second row, and the third row. Finally, I do it for the fourth row. So let me do that in here. So the fourth row. And I'm not going to write down the rest because it's for the new matrix. So we know that. So let's see. The fourth row, to do that one, I need to, of course, know what is the fourth row in my original matrix or array. So it's B3, B7, B11, B15. So let me write it down. So the last, the fourth row will start like this. And remember, I have to do the shifts. So it's going to be B3, B7, B11, B15. That is the original. The last row of the original matrix. And I have to do, because it's the last row, I have to do 3 shifts. So I will have to move the bytes, so 3 bytes. So I'm going to move, first I'm going to move the B3. So let me do that. So I'm going to erase it from here and move it to the beginning. So it's going to be B3. Then I do it again for B7. Move it to this position here. So let me erase it again and move it. B7. That's twice, and so I have to do it one more time. So I have to do it again for B11. So I'm going to move B11 here. So I'm going to erase it and move it to the position here. This will now be the new row of the matrix, of the new matrix, B15, B3, B7, and B11. So we have all the information we need now to make the new array. So we have the first row, which is this one, the second row, which is this guy over here, the third row, which is this one, and the fourth row, which is, of course, that one. So that's what my new array will look like. So okay, it's not, I haven't written anything yet, but this is my new, this will be my new matrix. Let's call that a matrix or array, whatever name you want to call it. It doesn't matter. So look, what is the new matrix? So I'm gonna write down my first row, and if you remember, my first row is exactly the same as the row of the original. So it's gonna be B0, B4, B8, and B12. Now remember, all those B are bytes. So all of those B are bytes, of 8 bits each. Now the second row, which this one that goes here, is of course going to be the second row of the new matrix. And if you go back, let me scroll all the way up here. My second row will be B5, B9, B13, and B1. So let me put that in there. So it's going to be B5, B9, B13, and B1, which is the second row of the new matrix. If you go back here to the, let me scroll up, you will realize that's the one we have here. B5, B9, B13, and B1. And so the third row will be this one, and the fourth row will be this. All right, so I'm just going to write it down here. So let me write down what we had. So the third row will be B10, B14, B2, and B6. And the last row will finally be B15, B3, B7, and the last one will be B11. And if you go and check, so it's exactly the last one there. That's over here. We can actually see in the same screen here. Yeah, B15, B3, B7, B11. Now this is the new matrix. Of course, the answer should not be a matrix or any array. It should be a byte 128-bit block. And you're going to read it like this. You're going to read it like this. Starting from the first column up, down. So the new, so let's say here, the new 128-bit block will be, I'm start reading the matrix like this. So it's gonna be, let me see, put it over here. Let me say B0, B5, B10, B15. That's writing down this column, and then I continue with the next one. So it'll be B4, B9, B14, B3. That's gonna be for the second column. Let's continue with the next column. Remember that whole thing is supposed to be just one block of 128 bits. So then the next one will be starting from here, from B8. So that will be a B8. Let me go to the next line. I cannot do it in the same line because I don't have space there. So it's gonna be B8, B13, B2, B7, and finally I'm gonna write down the last column. So that will be B12, B1, B6, and B11. Now this guy that you see right here, this one over here, that is the complete new 128-bit block, and it's 128 bits because remember every B is a bit or is a byte. So every B is a byte. So I will have a new 128-bit block. So really what happened there is you basically rearranged the bits or the bytes in this case, and also the bits of course, but the bytes in this case we rearrange them in this way. So the original was B0, B1, B2, B3, B4, and so on, but now is rearranged in the new way, and the way you rearrange it is of course the one we did it like this, shifting 0 for the first row, 1, 2, and 3 for the last one. All right, so what I'm gonna do is I'm gonna stop the video now, so because it's been a little bit long. I'm gonna go over this one more time with the specific example of bytes. So I'm gonna take an actual 128-bit block, and I'm gonna show you more or less how that works here. So I already know what I have to do. So I have to organize it this way. If I have an original 128-bit block, and it's B0, B1, B2, B3, and so on, I rearrange it like this. So I will do that in the next video.